Get a Job in Tech, episode 213. Recently, Intel was acquired or is being acquired by another company. NVIDIA, I believe, is the company. And when that happens, whatever Intel owns, NVIDIA is going to own. So, what does that mean? That means they have fabs all over the world. And more particularly, they have fabs in Taiwan, they have fabs in Ireland, they have fabs in Germany, they have fabs in other countries, exactly. And for instance, some of those places, now let's say you work in the States and you want to work overseas, but you're in the semiconductor industry. Perfect. There is a fab in Dublin, Ireland. There's a fab in Dresden, I think it is, Dresden, Germany. There's a fab in Poland. It's in Warklaw, Poland, and I believe it's Taipei, Taiwan. They have the fab there. So how it works is Intel themselves don't actually make the chips. It's their chip, obviously. What happens is Intel buys or pays for companies to process their wafers. Intel owns the wafers themselves, so they buy the wafers. The wafer comes in, it goes to a tool. The tool puts a layer on top of it. It goes to another tool, puts another layer, and so on and so forth. So what you end up with is you end up with a wafer. It's very thin, very small. It's about 300 millimeter. It has about, let's say, 500 chips on it. And if you look at it through a microscope, if you can look at it from the side through a microscope, what you're going to see is you're going to see something that looks like many, many stories tall. And it's going to be like floors. And if you can make the analogy, a floor in a skyscraper, many, many floors. Each one of those floors represents a process. Maybe copper usually is copper deposition. Could be other. It could be other chemicals as well, layered upon, layered upon, layered upon. And what you have is you can imagine, the skyscraper has the floors, and one floor, one room might be on. The next floor, floor two, might have a room and another room on, a light on. So if you can imagine, you have 10 rooms on each floor. So from left to right, room one, room 10. So you might have two or three rooms on the first floor turned on, and then the second floor you could have, let's say, 4, 5, and 6 turned on. Third floor could be 2 and 6. Fourth floor could be 1 and 10, so on and so forth. So what that is you have voltage going through the floors of the building, and that's where the process is. Essentially, that's the process. It's more technical than I can promise you. However, just for this analogy, that's basically it right there. It's applying power to every floor, and at the end result, you have a process essentially. So it might look like something like 1 0 for on or off, let's say, on off on off on off. At the end, you have all these numbers or these 1 0s lined up, essentially binary on and off, essentially, and that's what you're left with. So when they say the processing power, usually that's what they're talking about a lot of times. So put that to the side. Now let's focus on your career. You're in the semiconductor industry or not, how you can get in there. How you can get in there is they're always looking for individuals to work in these fabs. A fab is, you could be a cleaner, you could be a technician, you could be a manufacturing technician. Maybe you build the device. Maybe you're technically savvy or you're mechanically savvy. They always need people to do stuff in the facility. So they have a lot of deionized water in these fabs. Always have power. So if you know anything about power, they always need safety people to just make sure everything is good and safe. They always need security people. So when people coming into the fab, they show their badge. Okay, go up. They need those type of people. They always need IT as well, because all of these fabs need to be connected to the internet essentially, and they have to have phone lines. They have to have internet, they have to have computers, etc. Typically, when you work in a fab, you wear what they call a bunny suit, and it's head to toe. It's just a. Have you ever seen the Willy Wonka and the Chocolate Factory? That TV show, not TV show, the movie, the movie, and in it they have. So there's one with Gene Wilder, and then there's a new one with Johnny Depp, and I think there's another one after that. But anyway, they have this kid in there, and he has this jumpsuit on. Essentially, it's in a fab. That's what it looks like essentially. So you go in there and you go in the fab and then in the jumpsuit or the bunny suit and you do your work. And after you're done, you take off the bunny suit and then go home. Now let's talk about a little bit about robotics. So if you're in the robotics industry and you want to like look at something, the semiconductor industry is definitely for you. Anything like with automation or robotics is definitely semiconductor industry because how it works is the company that makes the robots for I know when I worked in the fab, Brooks Automation was the company that made our robot or it's a wafer picker, so it picks the wafer, places pick and place device. Brooks Automation made it, and all it is a robot with an arm on it, and it goes out, picks up the wafer, suction, moves the wafer somewhere, release suction, places the wafer, and what your job is to program it essentially. So if you can imagine a square piece of paper, and in the middle you draw a circle, okay, and you have let's say you draw a hand. Now that hand, let's say it's 2 inches out all around, so that hand can move 2 inches all around from the circle. So what your job is to do, essentially, when you teach a robot or teach a robot arm to do something, you're just plotting points. And you can name it A1, A2, etc. So what you're doing is you're moving the arm and then you set the station. You set it. Okay, good. That's station A or station 1, let's say. And then you move it to you move to another position. That's station 2, so on and so forth. And that's now, of course, that's just around, but that's essentially what you're doing is you're moving the arm, storing it, that's station 1 or that's station 1 or that's like, let's say it's station 1. Store it, move it again, store it to station 2, so on and so forth. And it takes a little bit of teaching it and making sure it doesn't hit anything else before you get it before it's completed. And once you have that, you're good. Then you just have the recipe, and recipe is nothing more than instructions that the tool has in order to plate the wafer. So a recipe might look like take the wafer out of the FOUP and put it to station 1. And now I'm referring to station 1 meaning the placement, meaning the area where the wafer goes. So you have on a tool, you might have 5 places or stations, let's say, or let's say 5 places. So place 1 or position 1, store it there. Okay, position 2, position 3, position 4. And so the recipe says, okay, move from position 1, move it to position 2, and do an action. Maybe turn it upside down and put it in the plater and wait. So the plating, it does its job. It's done. And position 3 would you go and pick up the wafer, turn it upside down again, or right side up, if you will. Put it in the spinner. So it puts it in the spinner, and the spinner, what it does is, or it's an etcher, if you will, it etches the end. Copper, usually they etch the copper on the other side. And then it cleans it, dries it, and then, okay, now the robot goes, picks it up, puts it at station 4, 5, or 6, or whatever. And then you're done. And that goes constantly 24/7. Usually these fabs that are overseas, they're either research and development or they're high value manufacturing. And there's definitely a need for chips out there and wafers, or chips rather, I should say. So you can expect India to be next in the manufacturing of it. They need a lot of water, so you could probably expect to see places like maybe Gujarat will probably have a fab in the next couple years. I would anticipate that, and maybe Italy, like the what is that? What's that little country below Italy? I think it's part of Italy actually. If they can pull it off, they can probably put a fab there, or Cyprus if they can pull it off. Maybe Turkey's going to have one. Nobody knows. France, obviously, probably have one. Helsinki or Norway, not Helsinki, but Norway or Sweden might have one in the future. Anywhere where you're near water and yeah, have redundant supply, and also what you need is you need a lot of technical people around as well to perform this work because after all, you're performing very technical, very technical skills. The fab itself is probably a couple acres big. It's very, very large, and you do a lot of work. There's a lot of money involved, and anytime that Intel, so what you can count on is this: if you're like an entrepreneur or a business individual, anytime Intel moves anywhere, if they put up a big fab anywhere, like whatever city it's at, they put a fab nearby in that location, you can 100% expect that area to grow and be big. And because there's a lot of companies going to be supporting Intel in the surrounding area, very large amount. Like Oregon, they have a lot of Oregon, California, like Silicon Valley, there's a lot of companies around there that their job is to support those fabs. They need maintenance people. They need AirSep is a big company. They need a lot of chemicals. Those companies are needed in that area. They need power people, like power companies. They need a lot of support individuals to work as a result or nearby the fab, supporting the fab essentially. And you figure what is it cost to chip, or what's a chip cost? $300, $400, something like that. So you imagine one tool is probably. So usually what happens is a company like, name the company, doesn't matter. Um, let's whatever company, Varian, Semiconductor, Applied Materials, whoever. What they'll do is they'll have a contract with Intel, and they'll charge them, let's say 3 million, let's say for a 5 year contract, let's say. So that what Intel gets is they get $3 million. They pay for the tool for $3 million. They also get technicians with that 24/7 for 5 years essentially because they're buying the tool and they're buying the technician. Now, of course, Intel pays for maybe replacement parts or something like that, but that's usually what they pay for, what they're going after, what they're paying for when they purchase a tool. And they have many vendors, many tools in the fab. And anyway, so let's say $5 million, and let's say $100 million. Let's say so they have what 20 tools. Let's say let's just say numbers. Each one of those wafers has 500 500 die, which is 500 actual processors on them. And so each one of those processors they sell for $400. That's quite a bit of money. And that's 500 wafers on one, or 500 chips on one wafer. Now, you have 25 wafers in each FOUP, and there's two FOUPs that can be processed probably every hour. It's not really that much, but let's say in a 24 hours you process maybe two FOUPs per hour. So that's 30 minutes each. So that's what 25 times 2, that's 50 wafers per hour. 50 times 24 times 400, and that's per day. And then that times by a year, and then that's what you get the number. It's quite a bit on it, quite honestly. And that's how they make their money, and that's how they keep in business. And that's Intel for you in a nutshell. The benefit also in Intel, I'll tell you in case you didn't know, they're very efficient, very efficient. Robert Noyce and Gordon Moore and another guy, Tony Anthony, forget his name, but they founded Intel, Essentially, it was Robert Noyce and Gordon Moore, but there was another person, Andy something, Goria, forget his last name, but I think those three founded Intel. And Robert Noyce, he worked at Philco before, and how Gordon Moore and Robert Noyce know each other, and Andy Grove, that's the guy. Well, I think Andy Grove might have worked at Shockley Semiconductor. Nevertheless, they worked at Shockley. They didn't like working there. They said, let's form our own company. And they worked for, let's say, they worked at Shockley. They didn't like working there, Semiconductor. Then they worked for another semiconductor company. I forget the name of it. And it was called a Traitorous Eight. And then from those eight people, they started Motorola, AMD. They went on to start Cisco and NetApp through like Bobby, Robert Valentine, um, Robert Noyce, and Gordon Moore started Intel. Now, when Steve Jobs, just a little history for you, when Steve Jobs was quote unquote excommunicated from Silicon Valley, when the when he was basically kicked off the board of Apple. Well, he went to Robert Noyce and he sought his advice, he sought his wisdom essentially. And because of Robert Noyce, Steve Jobs became a better CEO because of the input from Robert Noyce. He'd always bug Robert Noyce, like bug him about questions and how to be a better leader, etc. And Robert Noyce back in those days was considered the godfather of Silicon Valley. If he blessed your project, you got funding. That's how it worked. And unfortunately, now Intel is perhaps not going to be a company anymore. They're going to be swallowed up by Nvidia. Nevertheless, that's how it works in this technology industry. Thanks a lot. We'll see you next one.